Whenever you look up at a roof, what do you see? Probably just tiles, right? Most of us do. But underneath that simple, familiar pattern, there's this hidden world of engineering. So today, we're going to deconstruct something we see every single day to reveal the really complex system that's keeping a house safe and dry. Let's start peeling back the layers. Okay, so it all starts here with the absolute basics. The wooden frame, what builders call the rafters. This is the skeleton of the roof. It looks pretty simple, almost raw, but this structure is the foundation for every single clever solution we're about to add, one layer at a time. And that's the real question, isn't it? How in the world do you turn these bare wooden beams into an impenetrable barrier, something that can fight off rain, wind, and even unwanted critters for decades? Well, that's the journey we're on today. So here's our game plan. First, we'll talk about a roof's real job. Then, we're going to build it layer by layer, making sure that foundation is perfect, adding the first real defense against water, putting in the structural skeleton, securing all those vulnerable edges, and finally, revealing the entire hidden system at work. So, what is a roof really for? It's not just a lid you stick on top of a box. No way. It's an active defense system. And it's engineered to fight a constant battle against the elements. We're talking water, wind, and even pests that are trying to move in. This quote just nails it, doesn't it? A roof is a system of clever solutions. Every single piece we're about to look at, from the tiniest screw to the longest beam, it's not there by accident. It's a very specific solution to a very specific problem that nature is throwing at the house. All right, let's start building. And we're going to start with the first principle of roofing. The foundation has to be perfect. Before you even think about waterproofing or tiles, the base has to be flawless, because if this part is wrong, the entire system is compromised from the get-go. And it all comes down to pure geometry. You see, builders will measure the diagonals to make sure they're exactly equal. They check that the gables are at a perfect 90-degree angle. And why? Because even a tiny, tiny error here will throw off the alignment of every single layer that comes next. It's all about precision. And speaking of precision, here's another number you have to know: 9 degrees. That is the absolute minimum pitch or slope that this roofing system is designed for. Any flatter than that, and gravity just won't be strong enough to pull water off the roof. And that means leaks, no matter how well you build the rest of it. Okay, foundation is set. Time for the first real line of defense against water. The best way to think about this next layer is like a massive, high-tech raincoat for the entire house. It's designed to catch any little bit of moisture that might get past the tiles. And the process is really systematic. First, you roll out the membrane horizontally, starting right at the bottom edge of the roof. Then, you staple it directly to the rafters to hold it down. And then, you roll out the next layer above it, but with one absolutely crucial detail. And here it is, that crucial detail. See these printed lines marked 150? That tells the builder they need a mandatory 150 millimeter overlap. This is what guarantees water can't slip between the seams. It creates this continuous shingled surface, kind of like the feathers on a bird's back. This overlap, it's completely non-negotiable if you want a waterproof seal. So the raincoat is on, but you can't exactly attach heavy tiles to a soft, flexible membrane. The roof now needs its real strength. It needs a structural skeleton that's going to support the weight of all those tiles and give you a precise grid for placing them. And these are the battens. And you guessed it, just like with the foundation, precision is everything. The standard spacing or gauge for these horizontal battens is 350 millimeters. That measurement is what ensures the tiles are going to overlap just right and lock into place perfectly. But check this out. This is where it gets even smarter. That 350 millimeters, it's not a hard and fast rule. Look at this table. The spacing, that L, it actually changes depending on the roof's pitch. So on a steeper roof, the battens are spaced differently than on a shallow one. The system is literally adapting its own skeleton to handle the physics of water flow and weight. Okay, so the main surface is now waterproof and it's structurally sound. But what about the edges? The eaves at the bottom, the verges on the sides. These are the most vulnerable points on the whole roof. It's where wind and water are going to try to force their way in. They need some special armor. And once again, the system adapts. For lower pitched roofs, like you see on the left, you use an internal flashing and this ventilation mesh. But for steeper roofs, on the right, the design totally changes to an upper eaves flashing. The engineering is different because the way water runs off a steep roof is just way faster and more aggressive. Each solution is tailored to the physics of the situation. It's pretty cool. Now, take a look at this. We've talked a lot about water, but this protective mesh roll, it's for a whole new threat. What do you think this could be for? It's not for water, and it's not structural. So, what other kind of invader is the roof designed to fight? And here's the answer. That mesh gets installed right along the ventilation gap at the eaves. Now, that gap is essential for airflow to stop condensation building up, but it's also a wide open door for birds, mice, insects, you name it. This simple roll of mesh effectively seals that gap to pests while still letting that crucial air circulate. It's a brilliant, low-tech solution to a really big problem. Okay, let's talk about a key term you hear a lot, flashing. Basically, these are custom-shaped pieces of metal, and they act like that detailed armor for all the joints and edges of the roof where water could sneak in. You know, around chimneys, in the valleys, and along all the edges we've been talking about. And it's not a one-size-fits-all kind of thing. The system uses all these specialized pieces. Eaves flashing for the bottom edge, verge trims for the slope sides, and barge flashing for the gables. Each piece is precisely shaped to armor its own specific spot on the roof. So let's just take a step back for a second. What have we actually built here? We haven't laid a single tile yet, but what we've assembled is a complete interconnected system. It's a hidden machine right over our heads, designed for one purpose: protection. And this is the result. It's a perfect grid of battens, sitting over a sealed membrane, with every single edge armored by flashing. It's this complex system of wood, sheeting, and metal where every single component has a very specific job to do. Now, and only now, is it finally ready for the tiles. So the next time you look up at a tiled roof, I want you to remember this. You're not just looking at tiles. You're seeing the very top layer of this hidden, adaptive system of engineering. And the real question is, can you now picture all of that incredible work that's happening just underneath the surface?